Okay, let's go ahead and get started. So, hello everybody, welcome to today's webinar. We are going to be talking about performance validation in the context of blasting and pit slope performance. Thanks for adding your comments to the chat. Looks like we've got people from Alberta, London, Australia. Fantastic. Great, thanks for joining. All right, I'm just going to give a little bit of background about the Geotechnical Center of Excellence we're putting today's webinar on. So the GCE, we're an industry-funded and member-led group, and we pride ourselves on bridging gaps between and within academia, industry, and fields of study. And we do a lot of collaborative research as well as educational opportunities like professional development courses, webinars like the one you're tuned into today. And we do this all through our membership group. So without our members, none of this would be possible. So I want to give a huge shout out to our members. Here's a list of them. You can see it's a who's who of the industry. You can see there's different membership tiers. If you are interested in becoming a member, please reach out to us at the GCE. You can email us, gce@arizona.edu. You can find any of us on LinkedIn, get a hold of us however you want. We'd love to start that conversation with you. So today's webinar is based on our blasting and pit slope performance course. This is an online course. All of our courses are online asynchronous. If you'd like to learn more about it, you can scan the QR code here. I'm also going to ask one of my colleagues to put it into the chat for you. So once I click off of this slide, you can have access to it. So this course would not be possible without the help of our lead technical advisors, Pat Jenks, Phil Morris, and John Silva Castro. So a huge shout out to them. They're all joining us today as expert panelists, and I'll formally introduce them in just a moment. And also, I want to acknowledge the Large Open Pit project for underwriting the course. So just a little bit of housekeeping. If you're joining today, you are muted and your video is off, so don't need to worry about that. If you want to ask a question, which we highly encourage, please use the Q&A function in Zoom. It looks very similar to the chat function, but it's specifically for questions and answers. So please use that. It helps us identify the questions more easily. You can pose your questions anonymously. You can also vote for other people's questions. You can give them a thumbs up, and that helps us kind of high grade them. This is also a recorded webinar, and we're going to post it to both the course site and also our YouTube page. So if you want to view it later or send it to somebody, you can find it on YouTube and so on. Just a quick disclaimer. Please note that the views and opinions expressed by our panelists are their own and do not necessarily reflect those of the GCE or any affiliated organizations. All webinar content is intended for educational purposes only. It is not intended to be a substitute for site-specific professional advice or analysis. So thank you for bearing with me through that. Just a couple of introductions. So starting with the GCE webinar team, I will be your moderator for today. My name is James McNabb. I'm a senior research and development engineer here at the GCE. I'm joined by my colleague, Julia Potter. She's the director of the GCE. Hello, Julia.
Hello, James. Hello, everyone. Thanks so much for being here today.
We're also joined by Cheryl Bukowski. She's our professional development program lead. Hello, Cheryl.
Hi, thanks, James, and welcome to our webinar today.
And the two of them will be working hard in the background to make sure everything is running smoothly. So much appreciation to them. So I'm going to introduce our expert panelists, starting with Pat Jenks. He's the manager of geotechnical engineering with the Nevada Gold Mines, and he is also a lead technical advisor for the course. Hello, Pat.
Hello, James. Hello, everyone. Welcome. Glad you could join us.
Next, we have Phil Morris. He's a mine engineering consultant with Phil Morris Mining Solutions. He is also a lead technical advisor for the course. Hello, Phil.
Hi, everybody, and I hope that you're getting a lot from the course. Looking forward to today's webinar.
Thanks, Phil. It's very early for Phil, so we appreciate him joining. Next, we have John Silva Castro. He's the director of Dino Consult Value Capture Global, and he's a lead technical advisor for the course as well. Hello, John.
Hi, everybody. Thank you for being here.
Next, we have James Young. He's a principal advisor in geotechnical for Rio Tinto, and he is a contributor to the course. Hello, James.
Hello, everyone. Thanks for joining and happy to be talking to you all.
And I understand it's pretty early for him as well. So thanks for joining, James. Next, we have Ray Yost. He's a principal specialist in rock mechanics with Tetra Tech, and he's also a contributor to the course. Hello, Ray.
Hey, how's it going? Hello, everyone. Thanks for having me. Looking forward to the discussion today.
And last but not least, we have Michaela Bowers. She's not joining us right now, but she may be joining later. So just in case, I'm going to introduce her. She is the geotechnical superintendent with Nevada Gold Mines, and she is a contributor to the course. So hopefully she can join in a little bit later. So we're going to get started with some kickoff questions. These questions are posed to a specific panelist, and then once they are done answering their question, we're going to open it up to the panel. So we'll start with one for Phil Morris. So Phil's question is, what data is essential to make a credible post-blast assessment, and what data do you consider nice to have? Phil, if you'd like to get us started.
Yes, certainly. I think it's important, any comments that I'm making here referring to limit blasts and not to a normal production blast, which is remote from your walls. So from my perspective, a few important things obviously is that we must have at the basic relevant data for the rock mass, a lot of parameters, but for me, one of the things that seems to not get recorded a lot of the time is what the rock critical PPV numbers are, because they help to tell us how the fracturing is going to propagate through the rock at the wall. And then you need the design vibration levels that are predicted at the wall from your models. Second point, obviously, is that after the blast, you want to be able to see it and have a look at the blasted muck pile, looking for things like power trough, excessive heave, any obvious areas of poor fragmentation, and see how that relates to your planned initiation sequence and result. Third thing that I think most mines have now is that you've got video of your recordings, and video feedback from the blast is really a great way to visually verify if your blast vibration levels are reasonable at the slope, because you can see the shock waves propagating and the direction of those shock waves. And lastly, visual observation of the wall following excavation to see if the wall condition, and usually we're referring to pre-split barrels, whether you've got frozen toe and the like, will help us to see if our blast design against the wall was a satisfactory one. I mean, nice to have, and things that need to be done occasionally is to have some seismograph data to let you confirm that your near field PPV values at the slope are close to those that are predicted. I guess frequently you go to mine sites and there's a lot of design work done, but very little verification. And I think that's something that's it's a nice to have, but I think we could do it more often. Thank you. I think that's probably my response.
Great. Thank you, Phil. Thanks for getting us started. Would anybody else like to jump in on this one? If not, we can move on.
I think I just echo Phil's last point about the validation piece of that, and having adequate seismo data to assess your performance. I think, as he pointed out, that's a key piece of data that often gets overlooked or skipped because we don't have enough personnel to do it or to manage the data that comes from it. But it is really a critical aspect of assessing the slope performance as well as the blast performance.
Yeah, great point. All right. Thank you, Phil and Pat. We'll move on to the next question here. This one is for John. So considering a blast where the primary concern is vibration control, what aspect of the blast design or execution do you look at first when the outcome is undesirable?
there are many things that you can start to check here. From the design, I will check the timing. Timing between explosive charges, to see if ideally you are doing the waveform superposition to mitigate the vibration limits. Sequence, maybe sometimes if you don't pay attention to the sequence, you start to do things with the confinement. So maybe I will check that. And confinement, I mean, are we shooting the free phase or not? Of course, you have to check the record, the seismograph record, to see what other time, in what time the problem was presented. Sometimes even the charges, the loading, the steaming was the right one. You put more explosives, less. So all those records that we collect during the blast, I will check those, basically. Yeah.
Great. Thank you, John. Anybody else have any thoughts on this one?
Okay.
All right.
I'll jump in.
Yeah.
So one of the key things here, I think, is what John brought up about the firing sequence and understanding this blast pattern layout, and how that influences the confinement, because that confinement is going to influence that vibration and how you control it. A couple of our operations recently, we observed that for trim shots, they had designed in some rectangular shaped three-row trim shots where the burden and spacing was rectangular, and the long direction was parallel to the high wall. And the firing sequence they were using, it was the recoil direction was very orthogonal to the wall, and it was causing significant backbreak, significant ground vibrations that was inducing blast-induced slope issues. So one of the challenges that we faced was trying to convince them to change the pattern design so that instead of using a rectangular shape pattern, that we could use a square shape pattern and change the firing sequence and the timing so that we could pull that energy parallel to the wall and reduce the ground vibrations, which is ultimately where we ended up. It took some education with them so that and showing them the actual vibration performance from the seismogram data. We were successfully able to convince them that, okay, this is the direction they need to go. Don't use rectangular patterns, use square patterns, because if we're trying to control that firing sequence, minimize damage issues on the wall, pulling it from the long end of the pattern to a free face with the energy going parallel to wall, or recoil energy going parallel to wall was the route we really needed to go for long-term wall performance. So firing sequence, pattern layout, key and seismograph data are key components of that.
Great. Thanks for that, John and Pat. We're going to move on to the next question. This one is actually for Pat. So what does your blast to blast improvement loop look like? And how quickly can or should you implement changes while staying aligned with changing geology and conditions?
I think one of the first things to remember here is that this is a multidisciplinary challenge. So you need to make sure that we're engaging with all the key stakeholders: drill and blast engineer, geotech, drill and blast ops, short range planning, MRM, etc. Make sure that we're all on the same page, and discuss what you're seeing or you're observing in that blast performance at the blast master plan meetings, both in the office and out in the field. I often joke with people that, hey, you got to get out of the air con, and really we do to understand what's going on. But ultimately, one of the kind of the I like to follow is start by looking at the videos of the shots for the bench. Start with the production shots, then follow up by looking at the trim shots. Do you see any performance issues in the blast pattern? Is there evidence of backbreak in the video? Do we see any geological influences from fault or lithologic contacts that may influence that shot performance? Do we see energy troughs at the margin of the shot or the back? Do we see debris coming off the high walls above the shot? Maybe our frequencies are not correct. Do we have undetonated holes that's causing oversize or excess confinement and adding to ground vibration issues? Are there any other observed performance issues that might be related to point of initiation, timing, firing sequence, or excessive confinement? So the videos are a great tool to enlighten you and get you thinking about how to improve on that next bench. And then looking at the slope performance data from our monitoring tools, such as radar or prisms. Do we have evidence of blast-induced deformation in the radar or prisms? Let's start thinking about what we can do there. Oftentimes that manifests as an increase in magnitude of displacement and velocity temporally correlated with shot time. So what's going on with our monitoring tools? And then, review the vibration data. Are we at or below the targeted vibration and frequency thresholds, or above the frequency threshold? In reviewing that seismo data, do we see any changes in the performance? Could these be a result of changes in blast timing domains? Are we crossing a fault or lithologic boundary that's causing the vibration data or the vibration to behave differently? Do we need to collect additional signature holes to review with respect to those structures, the lithology or alteration, and develop new blast timing domains? Do we need to limit the shot across potential boundaries and then reassess them? Perhaps the ground vibrates and behaves differently on one side of a structure than another, and we can't find a timing that works to shoot across it. So maybe we need to stop before that boundary or shoot through that boundary and then pick it up again with a different timing. After we mine off the trim, do we need to review the bench performance? Or we should review the bench performance. Did we achieve compliance to the design? Are there crests and toes in the right place? Did we achieve the bench face angle? Do we have effective catch bench width? Did we achieve the DAC for catch bench reliability, 80-20, 70-30, whatever your design acceptance criteria might be? Our operations, for example, use the MapTech IRC tool to assess that, and it's really valuable. And, ultimately recall that there are two options if we're not achieving the catch bench reliability. The operational performance needs to improve, or the design needs to be adjusted. And I can't emphasize that enough. The catch benches are there for our safety element to protect our workforce from rockfall and spill rock. So it's our responsibility to flag this. And if we're not achieving the DAC, then we are accepting the risk. So we need to communicate that. Do you have a tarp in place to drive the necessary actions to change that catch bench width if we're not achieving it? For example, our wider catch bench is needed because we're routinely unable to achieve the bench reliability per the DAC. And then, things like if we're not achieving that catch bench width reliability, what are the bench performance issues that are causing that, or causing us to deviate from the design compliance? Is it crest loss due to backbreak? Are we shattering the bench above from excess subdrill? Is the trim not free face? We have too much confinement. Are there changes in the geology that we did not expect? Does that persist on the next bench? And that's a good conversation item to have with the MRM guys to help you make those changes. And ask yourself what changes might be useful to implement to improve that performance, timing, POI, firing sequence, etc. And most of those changes can be easily implemented on a bench by bench basis without too much difficulty. But we want to make sure that we're remaining flexible because that's going to be an iterative process. And if it's a big process change, then maybe we need to perform a formal risk assessment, or if it's a really, really big change, maybe we need to implement management of change to deal with this. And again, I just want to reiterate the importance of having a TARP in place to drive changes when we're not achieving that bench reliability. So those would be, and then ultimately repeat on the next bench, incorporating the learnings from the current bench. So that's a long-winded answer to that question.
It's fantastic. We like long-winded. Just out of curiosity, Pat, you mentioned filming blasts. I know a lot of operations are filming every blast, usually with drones. Is that something that your operations are doing as well?
We do most of them.
Yeah.
And the drone videos are fabulous because you can get in behind, if you're vending the back row, you can get in behind that and actually see that you're developing back brake from that trim shot. So yeah, it's an incredibly valuable tool.
Yeah, very easy to acquire as well.
Yes.
Any follow-ups?
Could I jump in on the second part of that question there?
Yeah.
This, how quickly can or should you implement changes while staying aligned with changing geology and conditions? This is a great question in terms of blasting, because obviously you want to get to that optimal blast configuration as quickly as you can. So you don't want to waste a lot of time doing things that don't work. But you also have to understand, sometimes things don't work for reasons that aren't apparent. And you kind of need more than one data point a lot of times. And I don't know what the exact number is. I mean, maybe Pat could weigh on this one as well from what he's done. But, for me, I like to see at least 3 kind of realizations of that particular blast design. So I can say, yep, I've got some variation. Maybe it worked really well. Here it didn't work so well. Something. But I see this not just in blasting, but in a lot of different things that we try in mining, where we'll go out and have an idea, we'll implement it, and it won't work for some set of reasons. Sometimes we don't even know. And we go on and do something else, and we're changing all these variables, and we don't always know what the impact of what the change is that we've made. And so you kind of have to keep things as consistent as possible for a couple of different trials, make 1 or 2 changes, keep that consistent for a couple of trials, and be pretty systematic about it so that whatever your conclusions are that you're drawing from that change, you've got more than just one data point from that change. And you also can track the change that you've made to the outcome that you've got in some way. So often I've seen where, again, we want to get to the right answer as quickly as possible. We'll be making all these changes. Something won't work in the end after we've changed it 6 times. And we'll conclude that, well, this thing doesn't work. But really, it's sometimes the process that's flawed. This process of how we tried to optimize something is flawed, not the actual idea itself. And so really this rigor in, again, being as systematic as possible. We can't be completely scientific in terms of doing, 100 trials and getting these really robust data sets. But we have to at least make some steps in that direction to say, we've been here, we've tested this out, we have multiple data points, and of course, if anything goes really wrong, you're going to change right away. But short of that, you can draw conclusions between cause and effect here. And it's not just we throw our hands up in the air and say we've changed everything and nothing worked, because that's not really often the case that nothing works.
Yeah. Excellent point, Ray. All right. Great, thorough answers from you both. Thank you for that. I think we'll move on to the next one here. This one is for Ray.
Okay, good segue.
Why does post-blast performance validation matter for the long-term success of a mine? And how should that knowledge be maintained and accessed?
There's actually quite a bit to unpack in all this. I'll sort of break it down into three different pieces. As far as why it matters, there's some practicalities. I mean, there's simple ones. Sometimes there's a regulatory or safety or stability need to track it. PPV, I think someone mentioned before about needing to do this. Sometimes it's a requirement. It could be part of your social license or your actual operating license to have to track some of these things. So it's like we have to do this as part of our operation. Probably in broader terms, in terms of success, there's a lot of specific practical outcomes that are really critical with respect to achieving your financial targets or revenue streams. A lot of these things are going to be, and we've talked about them a little bit, heave or dilution. This is going to impact grade control and dilution assumptions, which can have significant financial benefits to or financial implications to your revenue stream. Fragmentation is another one to track, where it's going to have all these different impacts to your, downstream subsequent processes with loading, hauling, crushing, conveying, all sorts of different things. Design conformance. Pat had mentioned that. This can affect strip ratio in a worst case, where you're just not meeting design, you've got to flatten slopes, and suddenly your strip ratio is a lot higher. So all of these things have financial implications to the mine. We make all these assumptions going in, and unless we know what we're doing and how we're doing with those assumptions, we have no idea what we're getting out. It's sort of like, it's just part of the whole process. This is, again, we've designed this thing, we've made a certain set of assumptions in order to understand what's working in those assumptions, or more importantly, what's not working. You really have to check those outcomes against those assumptions. It's almost, the scientific method. Each blast is kind of this little mini experiment. And those outcomes have to be tracked to go right into the next experiment that we run, kind of like what Pat was talking about. As far as how knowledge should be maintained, I'd love to hear from some of the folks at operations on this one. I can give some really broad overviews from things I've done. But you have to have a central storage area that all the stakeholders and relevant parties can access. You don't have to keep it in one file, but you certainly have to keep it in one place. I've done so much post-blast, assessment and validation, and the data is just everywhere. The ore control folks have a piece of it, and the D&B folks have a piece of it, and survey has a piece of it, and they're all in these different file formats. Some of them are in hard copies on paper, and some of them are electronic, and you have to put that all in one place. And all of the data relative to one blast has to be in one place. You can't just have this stuff from different blasts all over the place, or these different pieces from one blast all over the place. I think it's also necessary in terms of that file structure and how we're maintaining it, that you have to have a way to tie the design to the performance. You can't have these as two separate pieces that are in different places. You need to know what you did and then what happened from what you did. It's just about those linkages that I was just talking about, and a few other folks have mentioned, with understanding what did we hope to achieve here and what did we actually get. So to do that, you have to have this file structure that matches those two types of data up. And there's plenty more in there, I'm sure. Like I said, I'd love to hear from some of the operations folks in terms of some of the practicalities of how this works. As far as access, there's a lot of different ways you can interpret that part of the question. One piece is you've got all this data, that there's tons and tons and tons of data associated with any one blast. But there has to be some sort of reportable metric that comes out of it, some sort of thing that you want to get from it. It can't just be all this data that sits there, because you want somebody to go in and be able to do something with it, or look at it in a certain way, or compare it to some KPI or whatever. I've often seen where there's all this information, but no assessment of it. So part of this is first sort of developing these KPIs or these metrics, and then keeping up with them, so you're tracking it. So now you have access in terms of not just looking at the raw data, but looking at the assessments of that raw data. And you're looking at the trends over time. what's your design conformance? What's your fragmentation? What are all these things that we're looking at, and how are they changing with time? And this kind of maybe gets back to the more traditional way that we might interpret access, with who are all the different users accessing it. Because you're going to have people that need to be inputting all that data, tracking all the data, QA/QCing the data, assessing the data, updating all these key performance indicators, and finally just the people who are looking at the end use of it. So you might have, a lot of different controls around who you want to look at any one piece of that process. And, sometimes it's fine if everybody gets to see everything. Other times you want to have more control on the data quality, in terms of one person gets to enter it, one person gets to QA/QC it, and that's it. No one else gets to touch it. So there's a lot of different considerations in there. I mean, I think my answer, you could probably talk for an hour or so about all these different parts of it, but love to hear from some other folks in terms of how they've approached specific challenges with either maintenance or access.
Great. Thank you, Ray.
Phil here. I just might comment that we haven't mentioned the dreaded words QA/QC, and I think good quality QA/QC programs to make sure that you're actually doing all the things out in the field that you had intended to do, including the control of blast hole depths, particularly close to slopes and your final berms and things like that. All of that information is an essential part of the data collection process, rather than just the output side of how the fragmentation and the results went. So that's just an addition, I think, that's valid.
Yeah, excellent point. Any input from the operators? I see, James, you've unmuted.
I was just getting ready for the next question.
Oh, okay. All right. Great. Thank you, Ray. That was a very thorough answer. All right. Well, James's question is up next. Let's go to that one. All right. What field evidence or measurements most reliably indicate blast-induced damage versus pre-existing structure or scaling effects?
Yeah, so some of your first and most obvious ones that we got to look for in the field after excavation has happened, or even before, is irregular cracking, non-conformance along the crest line, irregularities along the crest line, just unevenness, loose rock, kind of a jumbled, shattered kind of look that's, not consistent with the geology, cracking that's just in proximity to the blast itself. So getting all the perspectives from above and below help with that and the recognition. And that gets better over time. As the group's been discussing, there's a learning process here, observation. So whatever you can get your hands on in terms of photos, videos, your record of completed performance sheets, you're constantly learning, so you're going to get better at being able to distinguish blast damage from the way the rock mass is expected to look. And just to note, in softer rock, the scaling is pretty obvious because you see teeth marks from the diggers. And in harder rock, you see a little bit of that too. But as you observe, 1.2 is to take the time to talk to operators. They're out there every day. They see the rock. They kind of, if they're digging it, they can feel how it's responding. if it's a blast crew, they're out there kind of next to the walls a lot. Good blast supervisor, knows how the various shots have been loaded, and they generally know if it's gone well or gone poorly. And so it's worth spending that time, because those are pieces of data too that you can pull into your inspection reports or logs or wherever you're keeping information. And again, the more you can do that, the better you're going to get at distinguishing when things have gone to plan and gone well, or not. A good final wall, should still have, relatively tight joints and structures, have pretty, like an evenness about it. And, look as you would kind of expect in terms of geometry, and what you know about the geology. And that's an important aspect too, knowing the geology beforehand, so that you kind of have a certain underlying knowledge of your rock mass. And so you know where your fracture patterns are, the natural ones, where some of your major structures are, hopefully, and you can see. And sometimes even when a blast goes wrong, it'll translate energy along a known structure, sometimes even an unknown structure. But when that happens unexpectedly, you can see it and you'll get press loss, or you can see it move up multiple benches. And, when you're looking at a blast video or any kind of information after the fact, being able to recognize those things, both the knowns and the unknowns, can be important too. In terms of measurements, the group has discussed vibration measurements. That can be a good indicator of when things have gone according to plan or not. If you've really exceeded your limits in that respect, and then you've put a lot of energy into your wall. So by the time you expose it and start looking at it, that'll help you tune in your observation to, okay, we know we didn't exactly pull that off as we wanted to. We got a lot of energy kicked back into the wall. Pay attention to what that looks like in your local condition. And in some scenarios, especially when you're under the water table, core pressure measurement can become a factor as well, in addition to the other monitoring forms that the group has mentioned. Because if you see unexpected spikes in pore pressure, that could be an indicator that the blast energy isn't exactly going where you want it to. So I think that covers most of it. But any follow-up questions or comments from the group?
Thank you, James. You mentioned talking with operators, with machine operators and so on. I think it's a really important point. I'm wondering if anybody here has given specific instruction or training to operators to look for specific geotechnical observations. Because I mean, they're, as you mentioned, they're there every day. They are very in tune with the rock, and it'd be great if they had specific training or knew what to look for and how to communicate that.
Yeah, absolutely. And if you're at, relatively best practice, you have a pre-designed bench plan that connects to a blasting domain that incorporates incorporates geotechnical data and geology. And so that is set, and you have a history of what you should be expecting in that blast domain. And the more mature the program gets, the better the operators will know that. And if that plan around a particular rock type or domain is known, and that historical performance is shared right through the operations teams, then everybody's looking kind of for the same things. And so, yeah, the more everybody is on the same page and talking about it, the better.
Yeah. Great. Thanks, James. Anybody else like to add to this?
Yes, James, just to add to your question, one of the key things we do is to educate those operators. And we do that through a variety of methods. We do that through our new hire training programs, our annual refresher training programs. And for key jobs or key roles, drillers, supervisors, the powder crews, etc., they typically take an advanced form of ground control that gets them educated on the things that we look for in the field. So they'll look, for example, the drillers. They'll be drilling a trim pattern and they'll report back, hey, I can't hold this hole for some reason. I'm wondering whether or not we have too much sub drill on the bench above. Can we consider adjusting that? So it helps with dialogues and modifying the design in that manner as well.
Yeah.
Just to add to that too, a lot of your operators are great monitors. I mean, they're great monitoring equipment in many ways. They're eyes and ears out there, and you can talk to them and interrogate them. They have, a wealth of knowledge often. We look at them for their operations skill, but I think one of the underutilized capacities of them is their observation skill. These guys know when something's different, or women as well know when something's different or when something's similar. They don't always have the technical background that, the engineers would have or the geologists, but they have way more just empirical data to share than we ever will, just going out in the pit once a day or something, or once a week.
Yeah, to Rick's point, I mean, that's one of the actual things we train to at NGM and Barrick is that the best monitoring tool we have are those 400 or 500 pairs of eyes that are in and out of that pit day in, day out. And it has led to precursors of potential failures and getting our heads wrapped around where we may be seeing evidence of issues. So it may not be that $600,000 radar that is this shiny object on the pit crest. It's that operator that's sitting in that cab that's seeing this high wall day in and day out. Yeah.
Yeah, all great points. Our monitoring tools do not have intuition, not even AI. All right, fantastic. So this last kickoff question is it was posed for Michaela, but she was not able to join us today. So I'm going to pose it to the panelists. It's probably geared more towards operators since she's an operator, but anybody's welcome to chime in on this. What does your post-blast assessment process look like? Who's involved, who's at the table, and who ultimately makes the call on changes moving forward? I think I can answer that last one, but not the rest.
Well, as far as who's involved, I think Pat had mentioned before that this is definitely a multidisciplinary endeavor. I mean, you've got almost everybody, the mine planners, the geoscientists, the resource folks, the operators, the drill and blast team, the geotechs. Depends on the scope of what we're looking at any one point. If we're really thinking about, hey, this blasting program's not working, we probably want to convene that full panel of people if one particular piece isn't working so well, you might get some subset. But there's a lot of different folks at that table in terms of looking at how that blast went and how the blast program is going, and are the changes that are being made working. Let some other folks tackle the first part of the question. As far as who ultimately makes the call on changes, it's going to be a fair few of those people at that. As far as who's involved, I mean, again, mine planning, drill and blast, geotech, all these people that really have a stake in this working, or a stake in the process working well. It's not just the D&B folks or the mine planners.
Right. All right. Thank you, Ray. Anybody else on this one? All right. So let's get to a live question here. It looks like we've got a couple now. Start with this one here. Okay. This is from the Q&A. A lot of the times we face a challenge from the theory side of things, suggesting the trim shot length or number of holes ultimately should not impact vibration as long as the rows of holes do not change and the pre-split is blasted before the trim shot. How did you come to tackle this specific issue with the square trim shot? So if I'm understanding this correctly, it sounds like there's a mismatch between the theory and the practice. I'm not sure if I'm interpreting that correctly or not. Maybe one of you knows better than I.
Well, I mean, at the end of the day, I think you really need to rely on the performance. And theory tells you one thing, but we don't deal with material properties that follow a very narrow range in strength or material characteristics. So theory can only go so far. I would really say that may help start you with some guidance, but you need to rely on the practicality of what actually happens in the field and go from there. But when we look at the performance of those trim patterns, for example, we want to understand that performance across the structures. Are we dealing with one alteration type of material? Is there a structure that the pattern crosses, and does it behave differently on either side of the pattern? And I could provide many examples of where we have a signature hole in one domain, let's say at the beginning of this shot, and we time the shot based on that signature hole data. And through that part of the domain, when that trim fires, the forecasted vibration is well within what we expected. However, when it crosses that structure, the behavior changes dramatically, and oftentimes you get significant amplification of the peak particle velocity, and the frequency will fall out of the range of what our frequency target is. So, you need to ask those questions. Think about that as you're setting up these shots. Have access to and review that seismograph data so that you can draw some conclusions from it. This would be pre-split, no pre-split. If you're just either way, if it's a pre-split that shot prior to the trim shot, or if it's just say a 3-row trim shot to final wall, the same thing would apply. And you need to have good monitoring for sure. If otherwise you're just guessing.
It's Bill here. If I could just comment from sitting on geotech review boards, which is what I still do, many times with the theory that you can have as many rows as you like, and it won't modify the control of the vibration at the wall. It doesn't seem to matter what you'd say about theory. The best results that I see come from minimization and control of the trim shots against the wall, keeping it to maybe maximum of 4 rows, never more than 5, smaller hole diameters, and a modified initiation sequence. Everything that you can do, everything that I've seen over the last 6, 8, 10 years says that extensive mixing of a production blast or very large blasts doesn't produce good results against the wall, and that we should always try and separate the production from the trim blast and not use modified production blasting, which is, I suspect, what the focus of this question might be.
Yeah, great points. All right, any other thoughts on this question? All right, thank you both for that. Let's move on to a couple questions here. This is a live one. So if we / a site want to improve blasting performance validation starting tomorrow, what's the first or most important thing to focus on? I think I saw that Ray was actually starting to address this one in the Q&A chat there.
Yeah, I was just going to say that it's that the documentation and the documentation protocols, not to beat that drum too hard, but you just have to know what you did and tie it to what came out of that, of what you did. And if you don't know this, you're just guessing at what's happening over here. I've seen this, happen frequently where you can't tie that result to anything because you just don't have this data. So really getting that documentation in place, and those documentation protocols where you've got all this data together is really, really key. There's about 6 other things though. I mean, picking one is pretty difficult. So be curious to see what other folks have to say.
Anybody else?
Yeah, I would say one of the things that I would like to see operations focus on, because I see this as a big issue at many of the sites that I visit, and that's we're not achieving our catch bench width, and that is a safety element to protect our workforce from rock fall and spill rock. So I think if I wanted to evaluate blasting performance to help with safety, one of the things I would pick on first would be to measure the catch bench width versus what the design intent was. And are we achieving our design acceptance criteria or that bench reliability? And if we're not, that we need to make changes to protect that workforce. I can think of a couple of deep open pits that I've seen recently where you look at the high wall and the catch benches for all intents and purposes are full. And you start to look down on step outs below and even the pit floor, and you can see that there are pretty big rocks that have reported to the bottom of that pit. But no one has made that link between we're not achieving our catch bench reliability and the safety of the workforce and acted on it. So I think that would be one of the first things I would target to start on.
I think that goes hand in glove too with setting that. I think you mentioned this before, Pat. Setting that KPI or that performance target around design conformance. You got to know what you're aiming at, or you're never going to hit it. You have to know what you want to get and what you want out of that blast, and then measure it against it and say, okay, are we getting these desired outcomes? So having that performance target, as well, having that system to correct the missing that target. Like, okay, we didn't get there. what are we going to do? What's the protocol we're going to follow to get back on track with this next blast? Again, if you don't know where you're going, chances are you won't arrive. So that process in place is pretty key as well.
Right. And one of the things I fear is that because this is a difficult conversation with the mine operators and the mine leadership, it doesn't happen. But it really needs to. As I mentioned earlier, and I've mentioned a couple of times in the presentations for this course, is that there are two options. And that really comes down to improve the operational performance. And if that's not possible, then we need to modify the design. And if we don't, that, like I said earlier, we as the site practitioners don't want to be accepting that level of risk. That's a level of risk that goes beyond us. That should be, if somebody wants to change the design acceptance criteria to say 50%, then that should follow management change, a formal risk assessment, and sign off by the appropriate levels of leadership according to the business's delegation of authority.
I like that approach with sort of saying either improve or flatten. It can be actually pretty effective. I had a site I was at, and it was pretty much what you were talking about before, just one long scree slope of, you'd see these little tips of the benches sticking out from just loose rock from top to bottom. And I was able to go back in and figure out, like, okay, here was the mine design. Here's what we'd have to mine it at, which was, I think, 5 or 6 degrees, maybe even 10 degrees flatter. It's like, okay, guys, either fix this blasting program or flatten the slope. And that tends to get a lot of attention because no one wants to flatten that slope. It's usually far less expensive to fix the blasting program. And that can help drive those conversations you're talking about. But yeah, a lot of times those can be difficult, which would be another thing I'd add to the list of the first thing to add is to start with education and why are we doing this? This is not just an exercise in fun and games. This has real reasons, and a lot of them are safety related reasons to make sure we're hitting those performance targets and protecting that workforce. This geotech stuff we do is not random. I mean, it's got a real driver to it. And getting people to understand that is sort of almost half the problem sometimes. These are the bench designs that we put into place for very specific reasons, and we have to meet them for very specific reasons. And if we're not, we've got to fix it.
Yeah.
One more comment, which relates to the cutbacks and things like that. It's you need to get this all sorted out while you're on intermediate pushbacks, because if you're already mining your final limit, if you do end up with any geotech step outs and slope angle reductions because you're not achieving your design acceptance criteria, you've got no comeback. It's just lost mineral at the bottom of the pit forever. Whereas if you're in a pushback situation, you've at least got the opportunity to recover lost mineral because of flattening the slopes when you do the next cutback. But because we have aggressive designs, it's really, really important that you get your act together before your final cutbacks.
Yeah. All great points. Just a plug for the course. I know Jason Garwood has an excellent presentation from NGM about auditing your slopes. And Chad Williams also has a great presentation about rockfall as well. All right. Thank you, everybody, for that. We've got a couple more live questions that have come in. This one from Paul gets back to operators and their observations. Do operators have mechanisms to self-report observations in the field in a way that is formally documented? How are these observations validated and appended to the model? Really interesting question, Paul. I'm sure that it depends. but I'd love to hear the perspective of our panelists.
I'd say, yeah, absolutely. And I mean, it will come down to your local site and how you've organized databases and documentation. But as we've mentioned before, the importance of using operator observation and capturing their thoughts, ideas, observations about what they think is going well and not well. And absolutely, if there's a form or a checklist or anything that you want to develop to, help them consistently get those observations down, then that absolutely becomes a valuable data set for you.
Mm-hmm. All right. Anybody else? Any of these ways that they can formally document, or is it just word of mouth?
Well, I think a lot of times too, this information is how it's collected and how it is stored is defined by the site ground control management plan.
Mm-hmm. Yep, great point. All right, thank you for the question, Paul. All right, let's move on. We've got a question here. This one is nice. It's quite broad, very practical question. Is there a mistake you see repeated across sites that would be relatively easy to fix? I'm sure we've got a lot of opinions on this. We've got people with many, many years of experience who've seen many, many sites. The problem is making it succinct.
Yeah. The one that comes to mind that I guess I can't say is relatively easy to fix is, falling into the functional silos and not communicating appropriately, not achieving that good feedback loop, and not getting good outcomes and escalations up to decision makers. It's it kind of naturally happens. Everybody gets kind of focused in on their jobs and their particular goals, and the whole stakeholder group kind of loses sight of what the blasting performance goals actually are. The operations team, mine planners, will tend to lean towards production KPIs and getting blasted muck and volume moved as quickly as possible, and that'll start to happen with impact on the high wall performance and long-term delivery of the geometry and design that you actually want. So it's not necessarily always easy, but for geotechs, like it's really important to get the safety goals and the design performance goals really front and center in all the stakeholder conversations. And for that to be effective, it's being able to communicate the consequences of if those goals don't get met, here's what happened. And the group kind of spoke to that before. You're going to suffer ore loss. And so if you can figure out ways to effectively communicate that you're going to, lose ore or have safety issues or both, that tends to get decision maker attention quickly. But then you've got to be prepared with what you're going to do about it and the changes that you need to see.
Yeah, I'd like to add to that. One of the goals that the GRBs that I attend, particularly a couple of mines or a couple of companies in South America, is that we've managed to have their key performance indicators between the groups, and particularly operations and the technical side of things combined, so that one of the primary KPIs for operations is actually achievement of the wall design, and for the technical group, it's achievement of adequate and maximum fragmentation for mineral throughput, because they're the two contrasting goals that are always a problem to resolve. But if you actually make people's hip pockets and their bonuses related to a shared KPI, it's amazing how quickly you can get rid of some of these difficulties between the various groups. It was a good point you raised, but there is a solution for that, I think.
And on that too, in terms of the ease, I mean, it's getting easier and easier to have somebody that, can operate a drone and provide, pretty detailed scans of your post-blast walls. I mean, this stuff that's available now is just fantastic, and being able to collect, surface data and plot it, practically in real time. It's not difficult to have a survey of the bench same day that the bench, that's done being excavated. So that part is pretty easy. And then, as Phil says, sort of getting everybody aligned with what's the goal here, and making them, making them feel it, as far as why do we want to do this? Get them aligned to that KPI. I mean, these things aren't easy on one hand, but they're also not hard. A lot of times it's just picking the right tool to use.
All right.
James, I would say that from my perspective, one of the biggest mistakes that I see really revolves around the communication piece on this, and not having a formalized blast master planning process and engaging with all those key stakeholders. I like to emphasize how important that is, because it is a multidisciplinary performance outcome. You really need to have that stakeholder engagement with the drill and blast engineering team, the drill and blast operations team, short range planning, geotechnical engineering, geology, survey, operations. You need to be discussing the pattern design. There should be a lift map layout for each bench that identifies where the pattern breaks are, includes the geology. You could talk about things like the timing and points of initiation, directional shooting. Historically, how have things performed? It should be including as part of that blast master planning process on the lift map, all faults, lithology boundaries, alteration boundaries, geotech domains. I mentioned the blast hole layout and pattern breaks. We need to set this whole program up for success. And I think that's a pretty simple thing to overcome. And somebody just needs to take ownership and drive it, make it a reoccurring meeting. And once you have a lift map, there needs to be formal sign off by all those key stakeholders that they buy off.
Yeah, great points. Ownership. And I want to echo Ray's comment about drone data. It's just so easy to collect. We mentioned it earlier, but if you're not collecting drone data, you really need to, because it's the videos, the post-blast surveys, they're just very, very useful. You can always go back to them. Really good data to have. Okay. Well, if we're done with that question, I think we're just about out of time. So I think I'm going to wrap it up with just a couple of closing plugs here. So I mentioned our professional development program. Here's a list of all of our courses. It's starting to be quite a lineup here. You can see we've got 1, 2, 3, 4, 5, 6 active courses, and we've got one new one launching in September, which I think I have a dedicated slide to. But I want to note that the Fundamentals of Open Pit Slope Design course now has Spanish captions, which is fantastic. This is a phenomenal course. It opened on September 16th of last year, 2025, but it's open for a whole year, so you can still register. We are working to get all of our courses in Spanish with Spanish captions as well, just for your information. Our next course will be the Geotechnical Fundamentals for Underground Mining. That it will release September 22nd of this year. So get excited for that. You can scan the QR code here to learn more about that and to register. So with that, I want to thank all of our participants today. Thanks for tuning in today, everybody. It's a great conversation. Really appreciate your time. Hope everybody had a great holiday as well.
Thanks, everybody. Happy New Year.
Take care.
Yeah,
Thanks all.
All the best.
Take care.